everybody, welcome back to RC with Adam. My name is Adam, and we have another great American 1-hour design challenge. We're going to design a squishy TPU infinity cube. It's going to have living hinges, and it's based on this design right here, made by Tailor Made Army on Maker World. So thank you for that inspiration. So it's pretty cool. So it uses living hinges. So instead of having to create hinges that like move, like two parts that connect, interlock together, it's just one piece that just bends, okay? And you can do that with TPU because TPU is a flexible material. And so I'm sure I have an idea in my head, but we're gonna figure it out as we go. And you probably are familiar with the infinity cubes. It's 8 cubes that are connected together in a certain way so that you can fold them and fold them and fold them and fold them to infinity and beyond. So that's really cool. And if this works out well, then we'll add them to the stealth collection at Fun Fidgets. Or maybe I shouldn't have told you that. So shh, keep that one on the down low. You didn't hear it from me. Please don't fire me if my boss sees this. Anyway, so let's get started. Let's go! All right, now we're in Bamboo Studio, and I have this model from Tailor Made Army of this squishy TPU Infinity Cube. So the main thing that I want to use this for is to keep track of how this is built. So you'll notice we have a hinge, and this could be done in different ways, but the main thing is you need to have a pair of blocks hinged in the same way. So in this case, we have the hinge here on the bottom, on these bottom blocks, and that's the first thing that prints. And then once the walls start coming up, we have pairs on either side, or from this view, the left and the right, with the hinge on that side. So hinge there, and then spin it around. Same on the other side. So symmetrical in that way. And that's probably one of the best ways to print this. We could figure that out later, but that's just the thing to keep in mind. So this should be theoretically super simple. One thing that I noticed with this one is the edges. I just wanted something that had like chamfered edges. I thought that would be better. And then the living hinge, we'll figure that out. And maybe a little bit thicker. I just broke mine, like just as I was beginning to start this video. I broke this one. I broke the hinge on it, but I've been rough on it. So it, and then yeah, it just broke apart. So now it falls all apart. So possibly a thicker hinge, possibly a thicker hinge, but now that I'm looking at this, I think what I did wrong, I'll bet I did not do arachne. I should have followed the directions, the instructions, and not actually connected very well to that. The top view, you can really see it. Let's switch to arachne just to show you this. And boom, look at that. It connects them. All right, now we're in Onshape. This is where we're going to design this. I have an idea of how to do this in my mind. I have not written anything down yet. So we'll see how this goes. So what I'm thinking is we do a sketch, shabwam, put it on the top plane, view normal to sketch plane. And then what we do is we get a center point rectangle, and we decide the size we want this to be. So the original size is, let me just get my fancy dancy calipers here. We're looking at about a probably 20 millimeter cube is what it was supposed to be. It's looking about 19 or something. So probably about 20 millimeters. I think that's probably a little bit big. Let's try, I've got the calipers here. I mean, probably 15 would be reasonable. Then what we're going to do is go up to the linear pattern tool, and we're going to select, or maybe we need to do that. Yeah, there we go. Select that for our linear pattern. We're going to do 4 in that direction, and 2 rather, in that direction. And then we get to decide the spacing, basically. So the spacing, what should the spacing be? That's a good question. That's a good question. Oh, I thought I did 4. There we go. I forgot to press enter. So The spacing should be even. I don't know, actually. Let's make it 1. Let's do 1 millimeter. That should be plenty. Let's give it a try. So what that means is the offset, or whatever it's called here, is going to be 16 for both of them. Yeah, both of them. So 16, 16. So we have this nice, super simple grid. There we go. And then what we're going to do is connect them. But first, let's just take a look at, let's use the extrude function and just extrude all of these cubes. And they should be cubes, so we want them to be extruded by 15 millimeters. Okay, nice, right? And then we basically just need to put walls, you know, on the connecting hinges. So I'm gonna try to not overcomplicate things. You know how I go sometimes. But we're gonna do it like this. So we have all these cubes, and then let me go back into the same sketch. Here we go. We're gonna just add lines connecting this gap on these the two middle cubes, and then we're going to we'll just go ahead and use a corner rectangle. These two, here and here, the two outer ones are going to be folding together. I'm gonna make this like 0.6. The thickness of the hinge is really what we're talking about. Okie dokie. So we have these connected, those connected. Great. Okay, and then actually, with as far as the extrusions go, we can extrude the hinges on the sides at the same time with the blocks, at least for how we have it right now. So those blocks are hinged together, and then we need to do a new extrusion because we will not be going up the full length of the block. So extrude, and then we're going to do our middle sections. Let's get that, come on, bring that sketch back. There we go. Our middle sections, both of them. There we go. And we're going to extrude, the height is going to be 0.6 millimeters. Which that should work out. We'll try it. We'll try it because I don't know about it kind of depends on the height. That's pretty darn thick, but that should be, I don't know, that looks really thick for how big the hinge is. Why do I feel like the thickness of that should be like half of what the gap is? I don't know, but basically the thicker this hinge is, the less easily it will move, and that could be a problem. But so I'll tell you what, just to test things out, why don't we make that one like 0.4, let's say. So that should be 1, or if we do 0.2 layer height, it'll be 2 lines, which is probably would be the same as the bottom thickness. We want to merge, just say merge with all. So we're going to merge those two together. Sketch 1, we only have one sketch. Do that to there, that to there. Connect those two like so. Okay, and then when we extrude, we'll do a third extrude. We're going to extrude that and that. At this point, though, we have to extrude up to this face. Second end position. So let's see, the first one is going to be up to face. Second one is going to be 0.6 millimeters from the opposite direction. 14.4. 14.4. Let's click add. Oh, I did click both of those, so that's good. Let's just say merge with all, because and then it's just touching those ones. So that's the idea anyway. Let's go ahead and play with the chamfering. So with the chamfering, we're going to get the chamfering tool, and then we would pick a section. We're gonna let's say we want it to be like maybe 2 millimeters, something like that. You know, so that's kind of the idea, is that we would do it on all the corners. Interesting. Okay, so the chamfering is not working out for a lot of these for some reason. Then I think it's because of the cutouts, the way the cutouts are. Interesting. Okay, so potentially it would just be chamfered on that outside. So let's go ahead and just export this guy. Let's drop that guy in there. Wow, it's so much smaller. Holy smokes. So let's slice the plate and just see what we've got. So, looks pretty similar. All right. Okay. All right, let's get away from classic. Let's go to Arachne. And there we go. There we have our walls. But as you can see, they're pretty small. They're still pretty small. And there's a seam right there. I don't want a seam right there. That is not a good spot for a seam at all. So let's just see if we can change where that seam is going to be. If we said it was at the back. Before I do any more designing, we're just going to load up the Bamboo Lab A1 printer with some TPU filament and just give this baby a whirl. Move that one off the build plate. We're just working with this guy right here. The main goal for this is for it to be silent and not have that clacky clack sound of the PLA. But making it squishy could be pretty cool too. And that could be kind of a neat little feature there. Now let's get it printing. All right, here it is. It printed out. Let's pull this out of here. I'll have to squeeze this off here. Of course, we can't really pop it off the build plate. We're gonna have to kind of pry it off. I know you're not really supposed to use the textured build plate for this, but I've used it before with TPU and it's worked out okay, but this is very, very sticky. Fortunately, it's a little bit of a smaller model, so we don't have as much surface area, but... All right, let's see what we have here. So, does it fold? Yeah, it does actually. And, you know, there's a little bit of a gap right there, so it's not a perfect even amount, but that works. It folds this way. And it should fold, fold on the sides. So 2 sides fold in. Fold in here. That's going to be the, so yeah, the sides. Right, so fold the top and then the side pieces, which are extra thick, really. So there's a lot of resistance here. It wants to spring out. Which some of that will go away as it gets worn in. And then very little resistance in this stage. Fold it again, and then it wants to fold back in on itself, which is kind of cool. This, by the way, is a clear blue Sane Smart TPU. I think it's also 95A. It's very squishy. It's nice and squishy. The chamfers printed nicely. They look very nice. I hope you can see that on there. So we can see the difference where this side has the chamfer, and then this side does not, and it's a very sharp 90-degree edge, which I don't like. I would say generally improvements for this one would be 0.5 millimeter gap between the cubes and probably 0.4 millimeter thickness for the hinges. Also, chamfering on all of the edges, if that is possible. It should be possible, because what we'll do is we'll chamfer it and then we'll model in the connectors, or the hinges, really. So then it will work. And I think also when it's in its cube form, I think it'll look really cool if we have some pretty heavy chamfers on there. That'll look nicer. But because as it is right now, it really wants to spring out a lot, and I don't really want that. Another option would be, you know, potentially doing like how I was saying, and adding like a little curve to the hinge. However, is that very realistic? Probably not. You know what would be really cool? Maybe maybe would be really cool is if you had magnets in here. Now that we have a good reference point with this first printed version, we can go back into the editing program, change a few little things that we just talked about, and then print another one and see how it goes. Probably increase the size a little bit as well. I think that would be probably good. Let's do it! So now we're back in Onshape. We're going to make some design changes to our first version here. What does that look like? 17 millimeters, and then 17.5. 17.5 is the spacing, so that we have 0.5 between them. So there we go, a little bit bigger. So we have the sizing. What I want to do here is let's try on this original sketch putting in a fillet. And we want to do a fillet here because it's going to give us a nice rounded edge, because we're going to be taking it up vertically. And so that generally on the vertical pieces you can do a fillet. On the horizontal pieces you want to do a chamfer. Let's do 2. Let's 2 millimeters. Okay. And this one and that one. Enter, enter. And great. So that's what that looks like. Looks like a nice cube. Now the question is, can we add a chamfer to the top of it? And how do we do that? Oh, well, yeah. And I think that's a pretty nice chamfer, so it should be nice and smooth. It is. Also, we want to chamfer the bottom, just like that. We also want to chamfer here because then we have this 45-degree angle, and we'll be able to stack the layers up just fine, especially considering we're working with TPU. We basically are. Delete sketch entity. Yeah, and then it's basically just making all of that like that, so we're basically starting from scratch. Now we can take this and take the shape, and you know, in some ways this is extra work, but the idea is that we are doing this once, making the shape once, and then we can just copy whatever we need to. So this is going to be 4 in that direction. This is going to be 2 in that direction. The distance is going to be 17.5 millimeters and 17.5 millimeters. And now we are back to our nice rounded cubes. So what I want to do is get a center point rectangle, and I want to find the center of this line, and then I want like the center between that. Do a corner rectangle using one of these radius points and just do it like that. Let's do a line, midpoint line. What if we took it all the way from here and all the way from here? So 0.4. There we go. That's what we want. Okay. We're going to do the same deal of attaching these two guys as well. So from that point to that point, and that point to that point. Extrusion. Extrude. So we want to extrude. So I guess this is the downside. I should have maybe done a different sketch for the other bits there, because then I'm gonna have to click on a bunch of stuff. All right, at this point it looks like, yeah, it looks like we have our nice cubes here with the rounded sides. We're gonna click OK. Next we want to do the chamfering. You get a chamfer, you get a chamfer, you get a chamfer, you all get a chamfer. Look under your seats. What is it? It's a chamfer. Let's click OK. And that looks pretty smoking right there. Look at that. Look at that thing. Wow, 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 wow. Wow. So, what are we going to do next? We changed the sizes, we changed the blah, blah, blah. Basically, well, we just need to connect the extrusion parts. I should have clicked on that in the first place, but that's okay. 0.4 millimeters. Okay, we want to merge. We want to add them with parts 3, 4, 5, 6. Great. So that looks really nice. So there you go. All right, cool. So that should be nice and smooth. Should print well. And then we're going to extrude, and let's go ahead and extrude the walls now. Shabwammo. So left side, second endpoint. I'm not totally sure how that's over there. So basically, if we say, hey, we want it to be like right there, which 2 millimeters, by the way, that is the same as the chamfer that we put on there. Add. We want add. So merge scope, merge with all. There we go. We have this nice face. It's going to connect right there. That should be just super great. 0.5 millimeter between here. I think that's reasonable, especially like just for the printing tolerances. We're going to want a little bit of tolerance, but we can change that if we want. Hear me out. Hear me out. Maybe we take 2 corners and do like a little ball divot. Because, you know, I can't just leave well enough alone. That would be crazy. Absolutely amazing. So let's do a sketch on this plane, on the left plane. Or the right plane. I guess it's whichever one. And then we're going to do a line. Take the line from this midpoint. Oh, we need to use this. And we're going to use this. And we're going to take a line and find this center point and just take it on down to here. And that'll be our reference point. We're going to do a 3-point arc. We'll take it from... I don't want to go quite to there, but let's just say if we took it from there and did it like... Is it going to be... Alright, scratch that. We'll just get a midpoint line. That way we know it's symmetrical. And let's just take it out to, I would guess, about... Oh, that's right, 12. That's what we wanted to do, right? We wanted to take it out to 12. Okay, cool. The difference here is that we are on the side of the of the object. So we're looking at a side view. Let's change that to Q so it's actually a thing. And then we have kind of this one, we should have this 1/2 chunk right here. Let me delete that and then put in another line from here to here. Oh, it's okay. We need to make that actually an actual line. So then we actually have a chunk. We will once we get rid of this. Okay, cool. Now what we can do is actually click OK, and then we can revolve. And so we're going to revolve 1/2 of this to basically form this bowl. And then the axis is going to be, we'll select axis. That's the axis. And then we're going to say remove. And then that's what we're going to end up with. So let's go to sketch 2. Let's go to the left side, and then let's use this line and this line and this line. Pretty much all the lines, really, just about. And what we're going to do is get a line and find the midpoint of this line from here to there. There you are. And just take that right across. We really don't even need to connect it to anything. It's actually just going to be a reference line because we're going to mirror this is, I think, probably the best way to do it. So we're going to say mirror, select the line. You always got to select the line first, which I think is the opposite of Fusion 360. And then that's the line we want. Is it? Yeah. Sure it is, yeah. Those should be connected. Those dots should be connected. And let's do that too. Great. And so we're like, okay, cool. And then we go to revolve, and then we're going to revolve this sketch as well. So we need to hide this, hide that. We're going to revolve that and merge with all. Let's show that part so we can see it. Boom. Bamboo Studio. Now we're in Bamboo Studio, and we're going to take the test 2 version that I just did, and we're going to put that in there. Okay. All right, cool. You can see it's a little bit bigger. It looks much smoother. I think it's probably just about the perfect size. It's much smaller than the original, or the other person's version here that the other designer made. It's much smaller, but still bigger than what I had. So I think that's cool. I think that's going to be really great. Let's go ahead and slice it, and we'll slice both of them side by side just so we can see the differences here. Okay. All right. Looking good. Yeah. well, actually not looking good because we need to change the settings on the new one. All right, I'm gonna toss this on there and then we're gonna print it and see how it is when it turns out. So let's start printing. Alrighty, here we go. It is printed. Let's pull up this build plate. Maybe this one will be a little easier to take off. All right, version 2. Let's see how she turned out. Let's see how much this sticks. Oh yeah. Oh, that's such an easier release. That's crazy. All right, so this one didn't turn out as clean. We have some stringing and whatnot. Oh wow, very thin, very floppy. I kind of like that, potentially. And then very easy to turn right there because the hinge part is so much wider. So you see we actually have a lot more play, which could be bad, but let's see here. So we do that and then we fold. So folding these guys, you can see we have quite a lot of stringing. Oh, actually, wait. So this is the bottom. This is the top. Okay. So it's between. Okay, so between these guys, we have a lot of stringing. So it could just be that, you know, the seam is in a bad spot and we're getting stringing here. We could adjust some settings as well. Or it could be that perhaps they were put too close together. All right, so because it's hard to tell where the actual hinge is and where it's not. But it's going to be on these guys. There we go. So you see right here, we have a lot of stringing going on. Like there's almost a second hinge because there's so much stringing. So I think if we take like a razor blade and kind of cut that. There we go. So that all that stiffness was just stringing. Same thing over here. Just lightly cut those little bits. Okay, so this feels a little too loose, a little too floppy, because we can like really wiggle this around a lot. I want this to be quite a bit closer. Also, interestingly, when we fold it, when we fold the bottom over or the top over on itself, you see how much extra like loop we have right there. So that's interesting. Kind of cool, but that hinge is really, really wide. And then this, trying to fold these back in this direction is not easy. I guess because all that stringing that's going on. Like, yeah, all this stuff that's going on here. Let's see if we can just super quickly hit that with the torch. Pretty bad quality on the inside there. Yeah, that's not super great. It's very smooth, but you see how it's like we can basically already fold it by the time we even get this in a position, which I don't care for that. So it needs more stiffness. It's better though. It's much better. The cubes are much smoother and softer, or the edges are softer, nice and rounded. So that part's nice. I think it's just we just got to get that hinge dialed in, and then the print quality, get that up to par. Yeah, because like that's not great. This should be all kind of tight together, and there's just too much space with that hinge, right? Or was that even? Did I even have that going right? Yeah. Yeah, that's right. But no, wait, that's folded because it was like that when it was printed. Yeah. Yeah, you see how we can twist this so much. So potentially thicken this hinge, increase the width on that hinge. It seems to be only the top and bottom hinges that are really like that. The side hinges aren't really as much of a problem, but you can see they do have like the curve. They do fold back over quite a lot. Okay, well that was pretty cool. I'm gonna probably keep plugging away on this design, but that's gonna do it for this design challenge. So thanks for joining me. This has been a lot of fun. Get out there, design something, build something, print something, fly something, and I'll see you again very soon. Let's get right back into it here. Let's jump into Onshape. So what we're gonna actually have to do in order to get rid of these fillets here, so let's just go to sketch 1. Lack of a better, more elegant solution, I'm just going to delete them on these parts. So extend, and then we're gonna press X, and then extend that line. There we go. Next, we wanna go to the chamfer. Let's just unchamfer all of the top ones. Tangent propagation, at least for this one, yeah. So turn off tangent propagation, and then right, so we just want those sides right there and there and there. Awesome. So now this is the bottom view, and you can see it's connected like that, but the other ones are chamfered and kind of the same on the top. Actually increase the size of the hinges, so you can see here this rectangle that we made the last time is 0.4. We're going to change that to 0.6. Hopefully nothing crazy happens. And then what's going to determine these other ones is going to be the extrusion. So we could do these ones. So this is our bottom extrusion, and so that's basically going up 0.4, and we want that to be 0.6. Let's say 0.6. This one, so the thickness is it'd be 0.4, so it'd be kind of like 2 layers, but one is a bridging layer and then the other is the actual layer. So we're gonna again change this to 16.4. We're on another side quest in case you didn't notice. So on that side we're gonna do brick. On this side, let's do another texture. Diamond plate, that seems cool. Oh my gosh. Tile, let's say subtract. What does that look like? Oh, no. Oh, okay. So what if we added that though? Oh, now we're talking. That's probably not a good idea for this particular one, because I think we should do that. Because when we print it, it's going to be like... What other patterns can we do? Oh, pyramids. 5 rows? I see. So that's going to change that amount. So we get like this waffle pattern. We have spheres. Ooh, actually, that could feel really cool. If we just made it really bubbly, you know? That looks like a really cool texture. Oh, yeah. That's a great texture. I'm going to do that same texture to this face right here. Sphere. So, fascinating stuff. And we're going to do texture on the opposite side. Oh, staggered. We're going to subtract them. These shapes should go into those shapes. What fun! So now we have all the textures to test out. Suppress, and then Shazam. They're all gone away. This part, I'm going to export this part. We can get back in here, and then we can select all of these. Unsuppress. We probably could have just hit undo as well, but unsuppress those. And then it's going to go bloop and bring everything back. So now we have all these really cool textures to test out and play with. There's one more texture I want to try out. Just one big bubble. We're going to subtract it, blah, blah, blah. Okay, great. And then we're going to do the same one over on the opposite side. And shabam. And okay, this is going to be very interesting. Alrighty, now we're ready to export this one. So now we're going to jump into Bamboo Studio. Alright, do some slicing. They're all stacked on top of each other. So, let's take a look. Get ready to nerd out on some nerdy slicing stuff. Alright, let's slice this mamma jamma. Let's go to line type. You see the bridging here. If we look at a side view, the bridging there. We're going to be at... This one has a very small bridge. 3 lines. This one has a very large bridge, 2 lines, and that is a bridge right there. So one of those 2 lines is a bridge. I guess I should have said gap, but and then look how large the bridging is right there. So night and day difference. Let's drag this slicer down. Is there an easy way to copy and paste the settings of one model to another? Because I don't know how to do that at this point in time, and I will probably figure it out once I make this video. So you can see on the one with the textures, we have a lot more going on as it's forming those walls. And interestingly enough, because of the textures and the way it's adding horizontal and vertical stiffness to the walls, it's not going to be nearly as kind of squishy as it was. And then, of course, the infill as well is giving us vertical stiffness also. Move everything apart. One wall, because that is pretty much how I want these to be able to be printed for efficiency and whatnot. Outer wall 0.6. We'll probably even go larger, but that's what we got for now. So the seam position, let's say back, and I'm curious if we do this. So what if we, so let's change this to like, let's rotate these. What happens if we rotate them? So back meaning the back of the build plate. And let's see where that seam shows up as we go. Oh, hey, that's a lot cleaner. That looks much cleaner, actually. So as we go, let's just look at our finished thing. So once again, the white lines represent the seams. They show us where the seams are in the print. Notice we don't have a whole bunch of seams, or at least on here it's not showing us that we have a bunch of seams on these hinges. On this one, actually, we have a ton. Like that's where all of the seams went. So, that could be because that is the back of that one, and there may not be a way around that either. Let's rotate that like 45, basically. So that could be good or it could be bad. All right, we got it sliced. Let's toss some TPU on our printer and print it out, and then we'll come back and see how it turned out. I'm getting off on a tangent. Okay, we'll be right back. Alrighty, here we go. We've got the two different versions off the printer. Let's set it down on the table and see what we've got. Oh yeah, they come off so easily off of this build plate that's actually intended for that. Imagine that. All right, cool. All right, let's see what we've got. Ooh, I like the texture. I like the textures here. With this TPU, the very small details are not super noticeable. I can feel the little kind of square shapes on this pyramid texture one that we did, and then I can feel more of the rounded shapes, a little bit smoother on there. On the side, we have the brick, which I actually like quite a bit. I think that's actually a really, it's kind of nice, kind of a nice texture. Kind of neat, a little something to kind of give it a little pattern to it, I think, instead of just like boring walls. And then we have our diamond texture. Oh, I don't know, I might like that the most. I tell you what, I'm really enjoying how squishy this is. It's just really fun to squish with this TPU. Whoa! Alright, so this big bubble right here, that's fun. That is a fun one. That's going to be really cool. The question is, will it actually work? These little bubbles here, they're kind of hard. It's almost like they're shaped to fit Legos, which I could see doing that. But yeah, they're not very nice, honestly. And also the negative shapes there, not very smooth. I actually prefer this kind of deeper one right here from this, on the opposite side of this bubble. But on this one that we actually designed, does not feel very good. On the underside, it failed. It's hard to tell. It's hard to see it with this filament and the light and stuff, but it's a big mess under there. So definitely not on the underside. You can see through these walls, or through the well, I guess this would be the bottom. So through the bottom layers, you can see the infill pattern. I think that looks really cool to be able to see that and how clear it is. So let's fold it. Oh, it actually fits. And I think also because it's squishy TPU, that really helps too. That actually fits really nicely. I like it. And then we get to see all these different patterns right here. So that's cool as well. That's pretty nifty. All right, so what's the next fold? So we fold it like this. And then we're going to fold these guys. There we go. Got to break it apart. Now, either my TPU is a little bit waterlogged, or I'm just going to touch it with a torch just to kind of break away some of those little threads, or possibly the cubes are too close together, and I really don't want to have to do this every single time as like a post-processing measure. So I don't know, we might fix that, but we're folding it. And then the next fold is like this. That's pretty cool. Okay, and then the next fold, and then it folds like that. So there's a lot of kind of like resistance, but also it also helps you fold it, which is pretty cool once you get it. Once you fold it a certain amount. So like folding it like this, it automatically wants to fold in like that, and then once we fold that one, these pop out. So it's actually really cool. I like it a lot. We still have it's very loose, you know, which is kind of okay. That could be okay, but I'm not super duper crazy about it. All right, so this guy, this big bubble, it folds, and it kind of, I like that it locks in actually. That might actually be a nice little feature. Yeah, I could see that being a nice little feature. Okay, and then we fold it back out. So it's really interesting because now we have this bubble piece very far away from where it was supposed to go into. Isn't that interesting? See? So it does actually, it ends up that far. So that is really cool. And then it's on the outside. And then it's back on the inside. And then it folds. I like that because you can kind of keep track of where it is. It feels more like a magic trick when it's like that. So I could absolutely see doing bubbles, maybe alternating bubbles, or bubbles all on one side, and then you fold them, and then you just go like that, and then that would kind of lock it in a little bit. Yeah, that's really cool. Yeah, I could totally see that. I could also see doing texture on all the sides. It's kind of nice that it's smooth on the side, like it's a nice soft squishy smoothness, but I think something almost like a wavy texture, something smooth. So not really. The diamonds are okay because the diamonds stay pretty smooth. The pyramids, they're not very smooth, and then the spheres on this side, not they're okay. They're okay, but I could see you doing these big spheres on all of those. I think that would be super sweet, and really, even on a I think a PLA one would work really well too. That'd be pretty cool. So that actually is. I mean, we're kind of there. All right, let's take a look at this one. This is the non-textured version. We have quite a bit of defects right here, some blemishes. It doesn't look super great. This one I did line infill and not very much of it, so it is very squishy. You can see all the line pattern compared to the this is rectilinear, and then this is line. The line is kind of sporadic and just crisscrossed and stuff. but let's give this a try. Okay. We have a lot of stringing, and I've been dehydrating this filament, so I don't think that's the issue. But then again, this is very old filament. Like, really, now that I think about it, this filament is actually like, how old is this? I don't know, 5 years old, maybe not quite 5 years, but it's been around a bit. Maybe I should try this with some different filament that I got, some newer stuff. Yeah, so it's being kind of weird here. We're getting a lot of resistance, like a lot of resistance. Let's do a little slice those little threads. Okay. Yeah, but you know, it's working. It is working. It's fun. You don't have the same like precision and kind of like rigidity of the PLA versions, but it's definitely something that could keep your hands busy, and is basically totally silent, which is cool. And I like this one because it has the textures, which are interesting. You can just kind of feel them and squish them. And it has the ability to, like, you can kind of keep track better about which block is going where, especially since it's all the same color. So I think that's pretty cool. Yeah, that's pretty cool. All right, I'm not sure what I would do to like improve this at the moment. I do think that part of the reason why it feels kind of just squishy and all over the place is because it is so squishy. There's very little, it's one wall. There's very little infill. It's actually quite really enjoyable to squish this, and it's cool how it comes back to shape. So it's almost like a stress ball. Yeah, you could use it like a stress ball. I'll have to do some destructive testing on this to see what this thing can hold up to. But I think that's going to do it for now. Yeah, and I may bring you along or give you an update on this as it progresses. But for now, I think we've made good progress. Thanks for joining me for another 1 hour-ish design challenge. I hope you learned something along the way. Thanks for hanging out, and get out there and design something, 3D print something, build something, fly something. Use your imagination, use your old thinking brain, and I will see you again very soon.